MikroTik OSPF area range. So we have here some basic OSPF multi-area setup. We have area 0, area 1, and area 2. We don't have much routers in our OSPF areas, but then again, this is just for demonstration purposes only. The OSPF multi-area should be set up already such that MTHQ should advertise, for example, the default route, so that MT site number 1 and MT site number 2 should have the default route when we take a look at the routing table. Loopback addresses for MT site 2, site 1, and MTHQ should also be redistributed. And this network in HQ, so we have 10.100.0/24 will also be redistributed to the MT sites. You take a look at each of our routers. So we are here in MTHQ. So running router OS 7.6. So if you take a look at the IP addresses, so there's one going to site 1. 10.0.11/30 on Ether 2. The other arm will be 10.0.2.1/30 on Ether 3. This will be our HQ network, 10.100.0/24 network on Ether 4. We have a loopback interface with the IP 10.255.255.1/32. And finally, rounding the IP addresses is our very basic IP DHCP client, which connects to our upstream router. So we have on Ether 1, this will be our connection to the internet. So we have router ID also configured. So 10.255.255.1, we name it router-ID on the loopback interface. As such, if we go to routing OSPF instances, and we have our instance configured, version 2 main, and we make use of the router ID. So originate default if installed, if there is a route or default route, and we will redistribute anything that is connected. Then we go to areas. So we have 3 areas because HQ is not only connected to the backbone. So we have backbone, OSPF-backbone. This is the area ID. We have area 1. This is the area ID. So the difference will be that one at the last. And we have the area 2. And this will be the area ID. Now for our interface templates. So the comment also determines the area. So for instance, for our backbone, that will be Ether 4. So this should be the network 10.100.0/24. For OSPF area 1, that will be Ether 2. So site 1 area 1. So the network will be 10.0.10/30. And finally, for our OSPF area 2, this one, site 2 on Ether 3. And we have the network 10.0.2.0/30. As for the MikroTik on site number 1, it is still using router OS 7.6. So we have its IP address. So going to HQ on Ether 1, that will be 10.0.1.2/30. We have a loopback interface, 10.255.255.2/32. If you notice, we don't have the one going to the site 2 LAN. So we will deal with it a bit later. So for routing router ID, so we configure 10.255.255.2. Again, the name will be just standard router-ID. We go to routing OSPF under instances. So we have just the same instance name, version 2, VRF is main, and the router ID. So we don't have any default route, so we will only redistribute connected. So we only have one area. So we have OSPF area 1 with this area ID. So we have area 1 for our Ether 1 interface. So as such, if we go to interface templates, we have our Ether 1 under the OSPF area 1. So if you notice, we have our networks blank just to show or make purposely this configuration. If we leave it blank, let's see if the neighbor adjacency will be formed on our HQ router. And we have our site number 2 router. So IP address will be pretty much the same. We have loopback and we have one going to the area 2 HQ. So 10.0.22/30 on Ether 1 interface. Then we have our router ID 10.255.255.3 on the loopback. Will still be the same router ID name. And as for site 2 OSPF, so we have instances. So we have one instance and we make use of this router ID name. In the area, we have only one area, that is area 2, with the same or matching area ID as for our HQ. And finally, our interface templates. So we have going to HQ on Ether 1, OSPF area 2, the network. So for this example, we configure the network 10.0.2.0/30. So just a quick verification if our OSPF configuration is working. So we are back in our HQ. So routing OSPF and we go to neighbors. So as you can see, we have two neighbors. This is our site 1 router and our site 2 router. Then it should have link state advertisements, but we can go directly to IP routes and see what are the OSPF routes in our main routing table. And we learn two routes from our neighbor. So we have DAO here. So we learn their loopback addresses 10.255.255.2 and 10.255.255.3. Likewise on our site 1 MikroTik router, so we learn the loopback of our HQ. We learn also the loopback of site number 2. We learn the default route, so we can go to internet, and we also learn the network of our HQ 10.100.00/24. This could be the same on our site 2 router. If we go to IP routes, so we learn the loopback of the HQ, we learn the loopback of site number 1, we learn HQ's network 10.100.00/24, and finally we learn the default route. So far our OSPF multi-area setup is working, except of course that we haven't introduced the site 1 and site 2 local area networks. So let's say on our site 1 we have the range from 172.16.00/24 down to 172.31.00/24. And our site 2 will have its range for 192.168.100.0/24 up to 192.168.100.30/24. So for our site 1 local area networks, so of course I could perhaps create many VLANs for that, okay, so for those subnets, but figure out that just a straightforward example will be to create loopbacks for it. So created a bridge, so it will become like a loopback. So the subnet 172.16 up to subnet 172.31.00. Correspondingly, they will be assigned with the appropriate IP address. So if we go to IP addresses, so we have from subnet 172.16.00/24 down to subnet 172.31.00/24. So now if you go to our HQ router and you take a look at the IP routes or the routes learned from our neighbors, so you'll notice you have a bunch of subnets that were learned from our neighbor, specifically our Site 1 local area network. So from 16 down to 31. So as you notice, it has a router flag with DAO, stands for Dynamic Active OSPF. Likewise, our Site 2 router will also learn our new local area networks from our Site 1. So if we go to IP routes, and yes, we are able to see the routes, so we are able to learn the routes. So 172.16 down to 31. Going back to our HQ and IP routes. So far as connectivity is concerned, yes, this is good. We are able to reach the Site 1 local area networks. But in the long run, this will not do well with our routers because, of course, each routing entry will consume resources. Then if you could see each of the destination address, okay, for example 172.16.00, it goes to the same gateway 10.01.2. so we go here 22.10.01.2 as well as 29.10.01.2, meaning to say, in other words, to be optimized, all the more reason to summarize or so-called aggregate these subnets, and hopefully it could be learned simply by just a single routing entry. Going back to our diagram, we now focus on how we could summarize this entire subnet 172.16.00 down to 172.31.00/24. Of course, there's a reason I've chose these subnets because these are the Class B private IP address that you could use, and they could be summarized to 172.16.00/12. But if you want to learn how it is done, of course you can take a shortcut. There are so many SuperNet calculators, so you will find SuperNet calculator, not subnet calculator. SuperNet because you are trying to summarize them back to one single aggregate subnet. So the idea in supernetting is you will find the bits wherein they are uniform or they are the same. So you start from left to right. So obviously 172 down to 172.31, they are the same on the first octet. So meaning to say the 8 bits are obviously the same to all of these subnets. Then if we go to the second octet, 16, 17, 18 down to 31, you'll notice this octet, second octet is changing. So this is where we need to find where from 16 to 31 they are the same in bits. So for simplicity's sake, we will make use of our good calculator that's available in our operating system. So turn the programmer functionality, wherein we could see the decimal to binary conversions of a particular number. Say for instance we have 16, so 16 is converted to 0001, then 4 zeros. How about 17? So 0001, then we have 3 zeros and 1. So notice the 4 bits haven't changed. In fact, the up to 7 bits haven't changed, and it's changed on the 8 bit. So for 16 and 17, the 7 bits haven't changed. But if you will go to the higher numbers, let's say 20 something, let's try it out, 27, you'll notice that it is not true anymore. And the only remaining constant are the 4 bits, which are the same. So you'll notice the 5th down to the 8th is also changing. So we could try 30 perhaps, is still true. And finally 31, you'll notice the constant are the 4 bits only. So meaning to say, the constant now is the first 8 bits of 172 plus the 4 bits on the second octet plus 4, 8 plus 4, is equals to 12. So we could summarize the subnets 172.16.00/24 down to 172.31.00/24 to 172.16.00/12. Again 12 because 8 bits from the first octet and 4 similar constant bits on the second octet. Then why it's 16? Because again the 4 similar bits across 16 to 31. So if you type 16, so if you have to clear this, so on decimal if you have to type 16, this is 16. Okay, 0001, again the 4 similar bits across to 31. So we will make use of the 16 because this is the conversion of the binary 0001. So to accommodate the new subnets, so for our site 1 router, so if you go to routing OSPF, so just remove the redistribute connected, and for the interface templates, as you can see, added the interfaces from 16 to 31. Okay, going back to our diagram, so where should we do the area range or to aggregate the route? So we should do it on the ABR, and because of a collapse diagram, we only have our empty HQ as our area border router. So empty HQ router is an area border router, so it has an area 1. So our area border router for area 1 as well as an area border router for area 2. If we configure the area range or the aggregate subnet for our empty HQ for this subnets, so it should now advertise an aggregate subnet to empty site 2 rather than the entire or the 172.16 range up to 31. Empty HQ would therefore advertise just a single route, the prefix range, and instead of the 16 routes that we have. On your left is your MikroTik HQ router. On your right is the MikroTik for site 2 router. As you notice, we have learned the routes 172.16.00/24 down to 172.31.00/24, and it is before we configure OSPF area range on our HQ router. We will now configure the OSPF area range on our HQ router. So we go to routing OSPF, and from here we find the area ranges tab. So from the area ranges tab, we click the plus sign. Under area, we will select area 1 for the prefix. We will type in the prefix that we have just computed. So 172.16.00/12. For the cost, we will leave it as default, and of course we will advertise. The routes are summarized now to, instead of the 16 routes, summarized to just only 1. But if you want to verify, okay, so to verify if indeed you still have reachability, really, let's say 16.0.1. Okay, click start. Yes, I have. How about 20? Yes, I have. And finally, how about 31? And yes, the site 2 has reachability to the subnets in area 1, specifically on site 1 router. Next will be our site 2 subnets 192.168.100.0 down to 192.168.100.3.0/24. If you do the super netting, these 4 subnets 100, 101, 102, and 103 will be super netted to 192.168.100.0/22. So why it is super netted to this? So 192.168 are the same across the 4 subnets. So the only difference is on the third octet, 100, 101, 102 to 103. This is the binary equivalent of decimal 100 and up to 103. You'll notice by careful investigation that the decimal 100 to decimal 103, they are the same on 6th bit. or they are the same up to the 6th bit. So we have 8 bits the same on 192 plus 8 bits same on 168. So 8 plus 8 is 16 plus 6 on the 3rd octet. So 16 plus 6 bits will be 22 bits. And why the 3rd octet is 100? Because the 6 similar bits, if you will convert it to decimal, it's 100. So in our Site 2 router, we go quickly. We have bridge for the 4 subnets. We have the IP addresses for the 4 subnets as well. And then if we go to routing OSPF, so just remove the connected to interface template. So we added the 4 subnets here. So on your left is Site 1, and as you notice, if we go to IP routes, we now have the 4 subnets learned via OSPF. So in the left side will be your HQ, and this is where we will configure the area range. So pretty much the same. Click the plus sign. This time we will choose the area 2. The prefix is the one that we have computed just recently, 22. Advertise. So correct area 2, click apply and click OK, and we'll see what are the changes on the Site 1. And yes, we have now the summarized route for our site number 1.